Hello everyone, my name is Gautam Hari. Today I'll be talking about the different types of EC2 instances, how they are named, and how we can differentiate between different instances, and how the families of VMs are broken down. Amazon EC2, which was created back in 2006, and it was one of the foundational services that AWS released as part of introducing the platform. And in essence, it's just a service to run virtual machines. Now, over the years, there have been many different virtual machine types created for different purposes, and we will talk about some of those in a bit. But as of right now, there's over 700 different variations, which we don't have to memorize all these variations, which is nearly impossible. But I'm going to show you what you need to know to be able to understand the name and family of some of those different VM types. Now, in essence, those 700 different VM types just have different arrangements of various components of RAM, vCPU, and some of them also have GPU capabilities. Some are more optimized for compute workloads, some are more optimized for network throughput or storage, and nowadays we even have the option of physical systems that are not really VMs at all. I'm going to give you details of how the families of virtual machines are broken down. Now, all the instances have names depending on what the name starts with. Tells us what AWS thinks the capability or specialty of the optimization of that machine is. Now, if one of our instance type starts with an M, that's just a general purpose baseline instance, which is good for pretty much anything. If it starts with T, that's a general purpose instance, but it's also burstable. Now, this concept is pretty advanced, which I'll be talking in further classes. If it starts with C, it's compute optimized. That just means it probably has more vCPUs and probably less RAM than maybe a general purpose instance. If it starts with an R, that generally means it's memory optimized. In other words, it has more RAM and less vCPU. Now, if it starts with a G or a P, it's GPU optimized, and those are best for workloads like video transcoding and machine learning. And then we also have I, D, or H, and these tend to be storage optimized. They tend to have enhanced IOPS to EBS volumes. Now, back in the day, there were many people who were training on AWS that tried to come up with these mnemonics that we could memorize what all these things are. But that was way back in the day, and things have gotten way more complex nowadays. So, for instance, we have the Mac instance type. These are physical Mac machines. These are not virtual machines. So we can provision a physical Mac machine if we wanted to. Maybe compile something for iOS or a Mac operating system. We also have HPC, and this is for high performance computing. Think like scientific simulations or weather simulations. We have the X systems, and these are really large memory. I'm talking like terabytes of RAM, and these are made for in memory databases like SAP HANA. Then we have a whole host of specialized instance types. VT for video transcoding. These have special Xilinx media cards that are really good at transcoding high resolution media very fast. Then we have TRN or INF. TRN for training, INF for inference, and these are optimized for machine learning training and inferences, meaning taking those machine learning models and spitting out predictions. We also have available to us field programmable gate arrays, that is FGPAs, and these are ultra specialized hardware that we can program that has a high degree of performance, but they are not as flexible as a CPU or a GPU. And then we also have the Z instance types, which are really all about just a pure high speed vCPU that can maintain a very high gigahertz consistently. Okay, let's look at a name for an instance. What's in a name? So, first of all, we have this M, and that M tells me this is a general purpose instance. If you remember back to our chart, M is general purpose. We have 7, and 7 tells me that this is the 7th generation. In other words, there was an M6 and there still available is an M6, there still available is an M5, and so on. Now there is an I. An I here tells me that this is an Intel based instance, meaning that it has an Intel CPU, and large is the relative size. I'll show you what I mean in a second. We can go to next example. For this example, it's a general purpose 7th generation, but here we have an A. An A here means that it has an AMD processor. So instead of an Intel processor, it has an AMD processor, but because it says large, I know that it has the same specifications. In other words, the same vCPU and the same RAM as the other M7i large. So look at another one, M7G. This G, that in particular instance type, has a Graviton processor. This is a CPU chip that's of Amazon's own creation. So a few years ago, they acquired a chip manufacturing company and then to work creating this host of specialized chips. And I think they did this for a few different reasons. First, they didn't want to be so relying on Intel and AMD for silicon. And second, I think they wanted to design some very specialized processors that better fit some of the unique use cases and the customers were bringing to AWS. And these processors are used in a variety of services and platforms within AWS ecosystem. Now, the thing to remember about Graviton processors is that they are an ARM processor. So it's not an x86 instruction set. It's an ARM instruction set. So you need to be sure that if you want to use these Graviton processors or these Graviton instances, that your software is compatible. Now, fortunately, there are plenty of Linux distributions and plenty of other software that does run on the ARM64 platform. And the benefit of running on Graviton versus AMD or Intel is that it's cheaper. So if you are looking to host some open source software like Nginx or something like that, certainly will work on an ARM processor. Architecture, and they might work out in the end and save you some money. Okay, so here we have three different instance types. We have an M7G large, an X large, and a 2X large. Now, the large instance has two vCPUs and 8 gigs of RAM. Now, the extra large has four CPUs and 16 GBs of RAM, and the 2X large has two times that of extra large, so it has 8 vCPUs and 30 GB of RAM. Now, if we keep going, let's say 8X large, how many CPUs and RAM do you think that one has? Well, if you have guessed 32 CPUs and 128 GBs of RAM, meaning 8 times the extra large, then you would be having a right answer. So, these are some of the basics information you need to know about how to differentiate between different instances types and its usages. I hope it was helpful for you. Thank you very much.